Good morning. Today I'll be going through the GCE O-Level Additional Mathematics 2010 Paper 2. Last night I did Paper 1 and I'm free today, so I thought I would do Paper 2 right here. So as I said with the paper that I did in Paper 1, the 2010 O-Level for A-Maths was actually relatively easy in my opinion as compared to what we see in later years. So I was once again not really surprised to see any of the questions within the 2010 O-Level papers. So let's, without further ado, get into the questions. So let me pull up my PDF. Okay, you guys can see that on the screen, right? Alright, so let's do the first question to begin. Question 1. Solve the equation 3 cotangent square theta plus 10 cosecant theta equals to 5 for 0 is less than theta less than 360 degrees. Okay. Alright, can you see this? Alrighty, let's do this. So we need to get these to the same term, right? So I shall use the identity that cotangent square theta is equal to 1 plus cosecant square theta. Okay? So let's do this. We have 3 plus 3 cosecant square theta plus 10 cosecant this is cosecant theta is equal to 5. Okay? Then let's bring this over here, right? Then we have a quadratic equation. We will have 3 cosecant squared theta plus 10 cosecant theta minus 8 is equal to 0. Okay? And this is our quadratic equation. Okay. How do I factorize this? This should be, yeah. So this will be 3 cosecant theta minus 2 times cosecant theta plus 4 is equal to 0, right? Yeah. Okay, so that means that cosecant theta is equal to 2/3, which has no solution, or cosecant theta is equal to -4. And this is what we will use to solve the question. Okay? So alpha will therefore be equal to the sine inverse of a quarter, right? And yeah. So therefore your theta, since this is negative, right, it will be third or fourth quadrant. So 180 degrees plus alpha or 360 degrees minus alpha. If you work this out, theta is equal to 194.5 degrees, or theta is equal to 345.5 degrees. These are 1 dp. Okay, so question 1, you just need to apply the identity that cotangent square theta is 1 plus cosecant square theta, then you should be good to go. Okay, question 2. Question 2, The diagram shows a triangular piece of land PQR in which angle PQR equals to 90 degrees, PQ equals to 8 meters, and QR equals to 12 meters. A rectangle QUVW is to be used as the base of a greenhouse where U, V, and W lie on QR, RP, and PQ respectively. QU is equal to X meters and QW is equal to Y meters. First part, show that Y equals to 8 minus 2X over 3. Okay? So we're going to consider similar triangles PWV and PQR, okay? Alright, I think you would have been able to see that the two triangles are similar, right? So then we can do this. We will have 8 minus y over 8 is equal to 12 over x. Right? Because we are comparing the... sorry, this is x over 12. Because we are comparing the ratios, right? By doing this, we are comparing the PW, this is PW, and then this is PQ, and this is WV, and this is like the QR, okay? So yes, now we're going to multiply throughout so we can solve this, right? So we have 24 minus 3y is equal to 2x. So therefore, 3y is equal to 24 minus 2x. So therefore, y is equal to 8 minus 2x over 3. Okay? So this is how you show it by considering the similar triangles. I will clear the board for the next part because even if you can't do part 1, you can still do the next 2 parts. Okay? So, question 2, part 2. Express the area A meters squared of the base of the greenhouse in terms of x. Okay. So we know that, so this is quite simple, right? So part 2. Okay, so we know that y is equal to 8 minus 2/3 of x. So the base of the greenhouse is just xy, right? So therefore a will be equal to 8x minus 2 over 3x squared. Think I didn't need to do that one. Given that x can vary, find the maximum value of a. Okay, so for that we must find dA dx, correct? dA dx is therefore going to be equal to, this will be 8 minus 4/3 of x, right? And for this to be for there to be a stationary point, we want dA dx is equal to 0, which means that when dA dx equals to 0, x is equal to 6, correct? And then a will be equal to, we sub the 6 into here, so we have 8 times 6 minus 6 squared times 2/3, which is 48, 24, so 24 square meters. This is the maximum area of the greenhouse. So yeah, that is also quite simple. Actually, let me just write this here. This is part 3. Sorry. So this is your 2 and 3. Yeah. Okay. Give me a sec. Okay. Question 3. There's in this simultaneous equations thing. I'll write those down before I show you the board again. So, without using a calculator, solve the simultaneous equations 32 to the x power times 2 to the y power is equal to 1, and 3x to the negative, 3 to the power of x minus 12 divided by 27 to the y power is equal to 81 to the 1 over x power. Okay? So these are our simultaneous equations. So let's look at the first one. We know that this is 2 to the 5x, right? Times 2 to the y. Okay, we can write 1 as 2 to the 0. Which means that 5x plus y equals to 0. So this is our equation 1. And then let's look at the second one. 3 to the power of x minus 12 times 3 to the negative 3y power, right? Because this is 3 cubed, is equal to 3 to the 4 over x power, right? That means that x minus 12 minus 3y equals to 4 over x. So this is our second equation. Now I'm going to sub this. So y equals to negative 5x. Then I will have x minus 12 plus 15x equals to 4 over x. I'm going to multiply throughout by x and then at the same time bring the 4 over so that I have a quadratic equation. Then that will be 16x squared minus 12x minus 4 is equal to 0, right? Then I will have 4x plus 1 times x minus 1 is equal to, sorry, there should be a 4 somewhere, right? This would be, minus 3. No. Okay, is equal to 0, and therefore x is equal to negative quarter or x is equal to 1. Okay, so these are your two values of x, both are applicable, and we will find the corresponding values of y. You just sub them into here. So this will be y equals to negative 5 over 4, or this is positive, right? Y equals to negative 5. So yeah, these are your corresponding values of x and y for this question. Yeah. So that question is a solid 8 marks. If you can get it, then good for you. In a minute, we're going to look at question 4. Given that the constant term in the binomial expansion of x minus k over x cubed raised to the 8th power is 7, find the value of the positive constant k. Okay, so binomial theorem. So we want to find the constant term. So we know that this is every time that we go up one term, this is going to go down by 1, this is going to go up by 3, so the whole thing will go down by 4, which means that the constant term will be the third term. So 8 choose 2 of x to the 6th power and then minus k over x cubed to the 2nd power. Alright, the x will all cancel out and this is going to be equal to 7. 8 choose 2 is 28. So 28k squared is equal to 7. K squared is equal to a quarter. And therefore k is equal to plus minus half. But the negative is rejected. Because this is it's given to us that it's positive. Okay? So your k is positive half. Part 2, using the value of k found in part 1, show that there is no constant term in the expansion of 1 plus x to the 4th power times the binomial expansion from earlier, x minus half over x3, right? Raised to the 8th power. Okay. So let's do this the normal way. So this will be equal to 1 plus x to the 4th power. We need to expand this, we need to expand the first 4 terms because we want to get the -4 term to cancel out the 4 here, so we have a constant term, right? Okay, so this will be, let's do it. So we have x to the 8 minus 8 times of x 1 over, okay, 7, 1 over 2x cubed plus 8 choose 2, which is 28, x6, 1 over 2x cubed squared, minus 8 choose 3, and 8 choose, oh my god, and 8 choose 3 is 56, so we have minus 56 x to the 5th power, and this 1 over 2x cubed raised to the 3rd power. Toka, I need you to be careful again. So maybe I'll move you a little bit, yeah, Toka? I hope you don't mind. Oh, lovely, I just touched my marker there. That's no issue. And this is equal to 1 plus x over to the 4th power times x8 minus 4x to the 4th power plus 7 minus 56 times this thing, which is a minus 7 x to the -4 power. Technically, there should be a plus dot 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 here, right? Okay, so let's do the binomial expansion. So to get the constant term, we can do x to the 4th power, we multiply by this, and then we will get -7, then 1 times 7 equals to 7, right? Okay, so let me write that. 1 times -7 plus 1 times 7 is equal to 0. Therefore, no constant term. The constant term is 0. Okay, so yeah, that's question 4. Binomial theorem. All right, I'll do question 5 and then I'll take an intermission because I need to settle something. And question 6 is proofs in plane geometry, so I will need to draw the diagram for that. So let's look at question 5. The curve y equals to 5 minus e to the 2x intersects the coordinate axes at the points A and B. Okay, let me just write that. So given that the line AB passes through the point with coordinates ln 5 and k, find the value of k. Okay, so let's do this. So it cuts the coordinate axis at 2 points. So we need to find the equation of the line that passes through those 2 points. If it cuts the axis, that means that we must equate one of the variables to 0, right? So when x is equal to 0, this one's easier, then y is equal to what? When this is 0, then this thing is just 1. So y is equal to 4. What about when y is equal to 0? what is x then? X is equal to, okay, we must get this to be equal to 5. So 2x is ln 5. So x is ln 5 over 2. Then we have two sets of points. We can use gradient formula. So let's find the gradient of AB. Okay, actually I can do this directly after I find the gradient, right? So gradient of AB is equal to y2 minus y1, x2 minus x1, right? So 4 minus 0 over 0 minus ln 5 over 2, and this is equal to, so the 2 will come up here, then it will be negative, minus 8 over ln 5. So the equation of AB is therefore y equals to negative 8 over ln 5 x plus 4, right? Because when x is equal to 0, y is equal to 4. Okay? So then we will sub x is equal to, x is equal to ln 5, right? So when x is equal to ln 5, y is equal to, let's see, so ln 5 will cancel out, then minus 8 plus 4 minus 4. Okay? So therefore, k is equal to negative 4. Alright? So yeah. Then for part 2, in order to solve the equation of x equals to ln of the square root of 9 minus x, a graph of a suitable straight line is drawn on the same set of axes as the graph of y equals to 5 minus e to the 2x power. So find the equation of this straight line. Okay, so let's see. So we are working with, okay, I think my classmate just messaged me. Anyway, we need to solve this. We have, so let's rewrite this as this. I will rewrite half ln 9 minus x, right? Because this was square root earlier, then I can change it to half, bring down the power. Okay, so we need to so to solve this, we can use e something, right? So if I raise the thing to e, actually let me bring the, actually this is x, isn't it? Sorry. So let me bring this over here. Let's multiply throughout by 2. Then 2x is equal to ln of 9 minus x. Okay. Then if I raise both sides to e now, then I can solve, right? So e to the 2x will be equal to 9 minus x. And we already have 5 minus e to the 2x plotted, right? So therefore, draw the line y equals to x minus 4, right? Yeah, okay, so that is the line that you can draw to solve the equation. Okay, just a little bit of algebraic manipulation to solve this question. Alright, welcome back. We're back today. I'm on question 6 now, the proofs in plane geometry question. Now, those of you who are sitting for AMATS in 2020, you will know that this is in your CLT. You will not be taking it this year because of COVID-19. But if you are watching this video in 2021 onwards, it will be applicable to you. So I think it's still important to go through it. The diagram shows a point x on a circle and xy is the tangent to the circle. Points A, B, and C lie on the circle such that XA bisects angle XYB and YAC is a straight line. Okay, let me just see. Yeah, the lines YC and XB intersect at D. So the first part is prove that AX is equal to AB. Okay? So we need to prove that AX is equal to AB. Let me just draw that line here. I forgot to draw that line. Okay, so let's see. What should we do? Okay, notice that the first angle that we need to consider is the angle YXA, okay? So we know that angle YXA is equal to angle of BXA, right? Because XA bisects angle YXB as given in the question. Okay? Then what we can do is I can use this angle and relate it to this angle XCY or XCA. Okay? So we can relate it because of the tangent chord theorem, which means that the angle over here is going to be equal to this angle, because this is the angle formed by a tangent and a chord, and it's equal to the angle subtended by the sector over here. Okay, so this will be angles on the segments, right? So angle XCA is equal to angle BXA. I should use YXA, sorry. So I will use YXA because of angles in alternate segments. Okay? So now we know that this angle is equal to this angle. Alright? Then we realize that this is a sector, and this segment is subtended by this triangle, but also this triangle. Okay? So therefore, angle XBA is also equal to it. Okay? Angle XBA is equal to angle XCA because of angles in same segments, right? Okay? And then we have basically just proven that angle AXB is equal to angle XBA, right? So therefore, AXB is equal to XBA by the converse of base angles. Actually, I should write the whole word here in this case. Angles of isosceles AX is equal to AB. And this is proven. Okay? So this is our little bit of our proof for our fact that AX is equal to AB, because they form an isosceles triangle, and we know that because of the base angles of isosceles triangles. Okay? I will clean that up because I need space to do the second part. Part 2, prove that CD bisects angle XCB. Okay, so CD bisects angle XCB, okay? So let's say that I have this tiny little angle here, this tiny line. So we need to find this angle. So we already know that this angle is equal to that. So if we can prove that this angle is equal to that, then we're done, right? Okay, and actually that's very simple. So you see that once again over here, we will have to use angles in same segments, right? So I have this angle to consider, but if I consider this angle, it will be the same. So angle ACB is equal to angle AXB because of angles in same segment, right? Okay, and because of that, and we know that we also know that angle XCA from earlier is equal to angle YXA, which is because of the, once again, the angles in alternate segments. Okay. Okay. So XCA is the same as XCD, okay? So since angle XCD equals to angle ACB, okay, I'm going to look at it as DCB. and D lies on, and actually D lies on the line that we want to prove is a PB. No, not a PB, just a bisector on CD. CD is the perpendicular. Why do I write perpendicular bisector? I think I'm used to perpendicular bisectors from proofs in plane geom. No, coordinate geom. Oh my god. CD is the bisector, angular bisector to be more specific, of angle XCB. Proven. Okay, so yeah, I'm used to perpendicular bisectors because of EMATS stuff, as well as coordinate geometry. But this is not a perpendicular bisector, this is the angular bisector. Okay? Alright, part 3 is also quite simple. In fact, part 1 and 2 was quite simple already, right? So part 3 is also quite simple. Prove that triangles CDX and CBA are similar. Okay, so CDX, CBA, right? Okay, so let's start with the angle of, we know that this angle is this angle because perpendicular bisector, right? Bisector. Yeah, so angle XCD is equal to angle, the order of labeling matters in this case. So angle is to ACB, right? CD bisects angle X CB, and angle, then we will see once again angles in same segment. Angle of CXD is equal to angle of BAD, right? Or BAC rather. Angles in same segment. Therefore, triangle CXB and triangle CBA are similar by AA. Alright? So yeah. So this shows that the two triangles are similar. Okay? So proofs in plane geometry. Yeah. Once again, if you're sitting for O-level in 2020, this is not applicable to you, but 2021 onwards definitely. Question 7 will be area under curve. Alright. I'm gonna do the second half of the paper now. I was busy all afternoon, so I'm recording this again. So we'll see question 7 here. The diagram shows part of the curve y equals to square root 2x plus 5 and passing through the point P and meeting the x-axis at the point Q. The line x equals to 2 passes through point P and intersects the x-axis at the point S. Lines from Q meet x equals to 2 at the points R and T such that QR is parallel to the tangent of the curve at P and RS is equal to ST. So find the equation of QR. Okay, so let's do that. So equation of QR, we know that the gradient is the same as the tangent at the point P, right? So y is equal to, so let's use what we have, square root of 2x plus 5, which is the same as 2x plus 5 raised to the half power. So we need dy dx, which is equal to, if you work this out, you have negative half power at the top, and then take down half, but this is 2 when you take the derivative. So everything cancels out, it is just the reciprocal of y. Correct? Okay, so then we know that that was at 2, so when x is equal to 2, dy dx, we don't need to consider plus minus, it is positive in this case, right? From our sketch, 1/3. Okay, so we have the gradient, but we need a point. So let's use the point Q since we know the y coordinate is 0. So when y equals to 0, then x is equal to -5/2, correct? So then we will have this equation, 0 is equal to actually I should put the 1/3 right first, 1/3, then -5/2 plus c, and then our c value is what? Our c value is 5/6, right? So therefore, the equation of QR is y equals to 1/3 x plus 5/6, right? That is your equation. Not too bad, right? Oops. Okay. And then part 2, I think you can guess, is find the area under the curve. So to be able to do that, we need to find out how to get that, right? So when you look at the diagram, you will see that we can find the area by integrating with the curve with limits of wherever q is, which is -5/2 up until 2, as well as finding the area of the triangle below it. Okay, so that is how we're going to handle this. So let's do it like that. Okay, so we're going to write the two equations again. Let's let the curve be y1. This will be square root of 2x plus 5. Then y2 is the equation of QR we found earlier, which is 1/3 x plus 5/6. Okay, then yeah, to find the area we need to integrate, and we also need to find the length of the QS and the RSST. Okay, so when x equals to 2, because we want to find the y value for y2, y2 will be equal to 2/3 plus 5/6, which is 4/6, 5/6, 9/6, 3/2, right? So, okay. So therefore, we know that QS is equal to 2 plus 5/2, which is 9/2 units, and RS is equal to ST, which is equal to 3/2 units, right? So therefore, we can find the area. So the area will be the integral of square root 2x plus 5 dx. The limits will be -5/2, right? -5/2 to 2 plus the area of the triangle, which is half times 9/2 times 3/2. Correct? Okay, so let's see. So, okay, so when we integrate this, the half will become 3/2. The bottom will also have 3/2, but then there's a 2 here, so it's just 3 at the bottom. So this is 3, then this is 2x plus 5 raised to the 3/2 power. Okay, and then the limits are, once again, -5/2 and 2. And then add the area, 27/8, right? Okay, so let's see. When we do the 2, we will have 9 here, right? Then 9 to the 3/2 power is 27, but there's the 3 here, so it basically cancels out. So we have 9, and then when we do the -5/2, you notice that the top is actually equal to 0. Whole thing is equal to 0. So we just do 9 plus 27/8. Okay? And this is equal to, this is 72/8, right? So this is 99/8 square units. Because when we do the integral, once again, substitute -5/2 is actually 0. So we don't need to consider that at all. So we just add the two together. Okay? So that's your area under curve. Question 8 is kinematics. Okay. You guys can read that for a minute. I'm going to clear the board again. Okay, two particles P and Q leave a point O at the same time and travel in the same direction along the same straight line. Particle P starts with a velocity of 9 meters per second and moves with a constant acceleration of 1.5 meters per second squared. Particle Q starts from rest and moves with an acceleration of a meters per second squared, where a is equal to 1 plus t over 2, and t seconds is the time since leaving O. So find the velocity of each particle in terms of t, first of all. Okay, so I'm going to name them in terms of p and q, right? So let's do this. Vp. Alright, this one is very simple because literally everything is given to you. Starts at 9 and then constant acceleration 1.5. So this is just 9 plus 3 over 2t, right? Because in this case, you are not considering, because everything starts from the origin in this case, there's no need for the plus c here in any of these cases for kinematics, okay? Alright, so that VP is simple. What about VQ? Okay, VQ starts from rest and has the acceleration of let me write down AQ, I guess, first. How about that? Okay, AQ is, is equal to 1 plus t over 2, correct? So that's what's given. So let's find VQ. VQ is equal to t plus, okay, this is t squared over 4, right? And that's it. There's no plus c in this case because it starts from rest. Okay, question part 2. The distance traveled by each particle in terms of t. So that is just a second round of integration, right? So we'll have SP. So let's integrate. So once again, no plus c because it's all from the origin. Okay, so this is just 9t plus 3 over 4t squared, isn't it? Simple enough. Then SQ is equal to the integral of this, which is t squared over 2 plus t cubed over 12, isn't it? Maybe I will write this a bit further down so it's clearer. Okay. Okay, so t squared over 2 plus t cubed over 12. Okay, I should write this as a big Q. Okay, so yeah, that's quite simple, right? Okay, hence find the distance from O at which Q collides with P. Okay, so that is the point where we will equate SP to SQ, right? So we have t cubed over 12 plus t squared over 2 is equal to 3/4 t squared plus 90. I'm being a bit inconsistent with the way I write it here. This is the same as half t squared and 1 over 12 t cubed. Okay, so let's write it like this. Everything's in terms of t here, which means that there will be something I can factorize, right? I can factorize the t when this is done. So let's multiply throughout by 12 first, and then also factorize the t. T times of hopefully my marker will last me some time. Okay, t times this will be t squared because I'm multiplying everything by 12. When I multiply this by 12, then when I subtract the two t squared terms, half minus 3/4, that will be minus 1/4, right? So that'll be minus 3t because I factor out the t, and then we are also going to subtract the 90, which is 108 in this case, and this is equal to 0, and then we will factorize the inside t. Okay, this is I believe this is minus 12 and plus 9, right? T minus 12 and t plus 9 is equal to 0. So therefore, t is equal to 0, which is rejected. T or t is equal to -9, which is also rejected. There's only one answer, or t equals to 12. This is the only answer we can take. T is equal to 12. Okay, so now we can just substitute the t into one of our equations. So when t equals to 12, then SQ is equal to, okay, so 12,144, right? So you have 72, and then this thing over here, T3 over 12, so it actually cancels out since it's 12, so it's just 144 again, so this is 260 meters. Okay? Can? That is our value. For the last part, it's just a small part, so I will write the part 4 up here, okay? So the last part is find the speed of each particle at the point of collision. So that is quite simple. You just substitute the t equals to 12 into my v's, right? So when t equals to 12, then we have SP is equal to, VP is equal to, so 9 plus 3 over 2t, so that is just 9 plus 18, 27 meters per second. And VQ, what about it? Okay, then we have t plus t squared over 4, so this is 12, 144 over 4, 36, so 48. Right? That's it. That's your kinematics. Total, this is 11 marks, so cannot lose out on your kinematics. Very, very important question. Okay, question 9 is coordinate geometry. I remember just now I was doing the proofs in plane geometry. I kept saying perpendicular bisector. It was disgusting. So, question 9. Alright, let's just read the first part first. The diagram shows a triangle ABC with vertices at A0, 5, B, 8, 14, and C, K, 15. Given that AB equals to BC, find the value of K. Alright? Okay, so using the length formula, I will solve for K, right? So let's see. This is 8 and 0, so 8 minus 0 squared plus 14 minus 5 squared will be equal to K minus 8 squared plus 15 minus 14 squared, right? Okay, so let's do this. So this is 8 minus 0, so this is just 8. Then this is 9, so this is 8 squared plus 9 squared. 64 plus 81, which is 65, 145 minus 1 on this side, right? So therefore, K minus 8 is equal to plus minus 12. So therefore, K is equal to 20, or K is equal to negative 4, which is rejected. Because we can clearly see that K is positive, right? So this is our value of K. Okay? Now a line is drawn from B to meet the x-axis at D and such that AD equals to CD. Find the equation of BD and the coordinates of D. Okay? So I will change this K now that we know it. So what we need to realize is that since it is also equidistant from A and C, that means that BD will be the perpendicular bisector of AC. So if we can find the gradient of AC, we can find the gradient of BD, and we know that D lies on the x-axis, right? Oh, my dad is messaging me. One sec. Okay, so this is now 9 part 2. Alright, so if we find the gradient of AC, then we can find the gradient of BD. Y2 minus Y1 over X2 minus X1. And this is just equal to half, right? Then the gradient of BD is equal to -2, isn't it? Because of the negative reciprocal. Then we have, we'll substitute our point. We have 14 is equal to -2, 8 plus c, which means that c is equal to 30. So therefore, the equation of BD is y equals to -2x plus 30, right? Okay? Yeah? Part 3, show that the area of the triangle ABC is 2/7 of the area of the quadrilateral ABCD. Okay? One second. Okay. So you can imagine that D is going to be somewhere around here, right? Okay? So one thing we need to realize is that the whole shape is a kite, right? Then triangle ABC and triangle ADC share the base AC, right? So that means that, well, you'll see, okay? So we will find the length of B to the midpoint of AC and then find the midpoint to D, right? So my marker is failing me. Let M be the midpoint of AC. Then M is equal to, let's see, so 20 minus 0, so this is just 10, and this is just 10, right? So this is just 10, 10. Very nice. Okay. So length of BM is equal to the square root of, let's see, so I have x2 minus x1, 8 minus 10 squared plus 14 minus 10 squared, right? And this is equal to, so this is 2, 4, okay, this is 4, 16, so the square root of 20, which is 2 times the square root of 5, okay? Then length of MD, MD is the height of the triangle ADC, isn't it? So same thing, square root, okay? So we will have to do x2 minus x1 again. We'll use 10 here. Now the x coordinate of D, we did not figure it out, but we know that if we just substitute y equals to 0, so maybe I'll write this on the side here. So BD is y equals to minus 2x plus 30. So when y equals to 0, D equals to 15. Okay, so therefore we know that, x is equal to 15. Therefore, D is equal to 0, 15. Okay, 15, 0. Okay, so we know that D is somewhere here. Okay, so let's do this. Let's do this. 10 minus 15 square. I'll change marker after this question. Plus, let's see, yeah, still 10 minus 0 squared, and this is just equal to 5 squared plus 10 squared, so square root of 125, which is 5 times the square root of 5. Ratio of BM to MD is 2:5, right? That is what we got from here. So therefore, ratio of triangle ABC to triangle ADC is also 2 to 5, and therefore ratio of triangle ABC to ABCD is 2 to 7. Okay, I'll write it as 2 over 7. Okay, so by comparing the fact that they have that the triangles have a common height, we know that the areas will have the same ratio, common base, but that means that the area ratio is determined by their height, okay? And therefore we can use that to make a statement about the kite, okay? I'll change marker. Okay, so we're down to the last two questions. Question 10, partial fractions and ln. So question 10, part 1, given that 3x squared plus 4x minus 20 all over 2x plus 1 x squared plus 4 is equal to a over 2x plus 1 plus bx plus c over x squared plus 4, where a, b, and c are constants. Find the value of a and b and show that c is equal to 0. Okay, so this is a very normal partial fractions with quadratic denominator can't be factorized. So let's do this. So multiply throughout. 3x squared plus 4x minus 20 is equal to a x squared plus 4 plus bx plus c 2x plus 1, right? Okay, so let's do it. Let x equals to, first thing we will do is let x equals to negative half, right? So that this thing is 0, and then we can settle this. So let's see. So this is negative half, this is quarter, 3/4, this is minus 2, minus 20. So minus 22 plus 3/4, 88 over 4. Okay, so then negative 85 over 4 is equal to a times, then this is half, so square, quarter. So this is 17 over 4. And then therefore a is equal to negative 5. Let x equals to, so let's let x equals to 0, okay? So that we can find the term in b, or rather c, sorry. Okay, then this is very simple. On the left hand side is just 20, and this is equal to minus 5, 4 plus c, 1, right? And then we see that this is already negative 20, so c is equal to 0, shown. In fact, we can just leave the answer as a is equal to negative 5, since that's what they're asking. They're not asking for us to rewrite this at the end. So let x equals to, we can't cancel anything anymore, so let's just pick a simple value like 1. Then we will have 3 plus 4, 7 minus 20. So minus 13 is equal to negative 5, 5 plus b, and we know that c is equal to 0, so we just write b times 3, right? Okay, negative 25, so b is equal to 4. Okay, so your a and b is negative 5 and 4 respectively. Okay, for part 3, I'm going to need this again, so what I'm going to do is I'm going to erase this, but I'll rewrite the values at the top, because I will need that for my little part. Sorry, I wrote that wrong just now. This should be minus 5 and this should be 4x. Okay, so now let us do the next part. Part 2, differentiate x squared plus 4, ln x squared plus 4 with respect to x. That's very simple. That's the f prime x over fx, 2x over x squared plus 4, isn't it? That's all. Part 3, using results from parts 1 and 2, find the integral of the expression we put into partial fractions earlier. So that will be the integral of minus 5 over 2x plus 1 plus 4x over x squared plus 4 dx, right? So this is how I will split my integral. I'll split it into negative 5 over 2. That because we want the integral in the form a over ax plus b to use ln, 2 over 2x plus 1 dx plus, then I want to get into this form, just take out the 2 times the integral of 2x over x squared plus 4 dx, right? So this is equal to, okay, this is negative 5 over 2 ln 2x plus 1, right? Then plus, yeah, so 2 times of that, so 2 ln x squared plus 4 plus c, right? Yeah, that should be your integral. Okay? We will proceed to the final question for paper 2 in a minute. I expect that this video will take about an hour to an hour and 10 minutes when it's done. Okay. So for the last question, we have a trigograph. So first of all, the diagram shows the curves y equals to 4 cosine x and y equals to 2 plus 3 sine x for 0 is less than or equal to x is less than or equal to 2 pi radians. The points A and B are turning points on the curve y equals to 2 plus 3 sine x, and the point C is a turning point on the curve y equals to 4 cosine x. The curves intersect at the points D and E. So first part, write down the coordinates of A, B, and C. For this question, I'm not going to sketch the diagram again, okay? So I'm not going to resketch the diagram for this question. 11 part 1 is quite simple. A is actually equal to, okay, so A and B are points on the graph of y equals to 2 plus 3 sine x, right? So those are the maximum and minimum points. And you know that when it's maximum minimum, you know that maximum is pi over 2. And then 2 plus 3 sine x, so this will be 5. And then B is equal to 3 pi over 2, that's where the minimum point is. Then this one will be minus 1. Okay, then what about C? C is the point, is the minimum point of the graph y equals to 4 cosine x. So that will just be pi and minus 4, right? Okay. So 11 part 1, I think is quite easy. Okay, so part 2, express the equation 4 cosine x is equal to 2 plus 3 sine x in the form cosine x plus alpha equals to k, where alpha and k are constants to be found. So this is kind of like your R formula, but the R in this case is 1. So let's get the form for R formula first. 4 cosine x minus 3 sine x is equal to 2, right? So now we can use our R formula. I'll have R times of the cosine x plus alpha, okay? So cosine x cosine alpha minus sine x sine alpha. Okay? So, and this will be equal to 2 later, okay? So then we have R cosine alpha sorry, is equal to 4. R sine alpha is equal to 3, right? Then we can square both of these, then we'll get R. So we'll get R is equal to, R will be positive in this case, so it must be 5, right? Okay, so R is equal to 5, and then we will take cosine. So alpha will be cosine minus 1 of 4 over 5, right? Okay. Then, but we don't want the 5 here, we want it to be 1 in the front. So let us express this. So then we will have cosine of x plus the basic angle, and cosine inverse of 4 over 5 is what? Okay, so this is let me write this as let's approximate, so 0.644, okay? So cosine x plus 0.644 radian is therefore equal to 2/5. Okay? So this is your thing. Can? So this is your kind of like your R formula, but we change it a little bit. We want R to be 1. Okay? For the last part, hence find the coordinates of D and of E. Okay? So, yeah. Where do I have space to do this? Okay. I'll cancel out this part and then rewrite this 0.644, right? Okay. So I'll cancel this part. Okay, so 11 part 3. I have cosine x plus 0.644 radian is equal to 2/5, okay? So then what I'm going to do is I'm going to write the basic angle as beta because we already used alpha earlier. So let's write the basic angle as the cosine inverse of this, right? The cosine inverse of that is 1.159, okay? Alright, so x, okay? So we need to find D and E, so that means that we need to consider the value in the first quadrant and in the fourth quadrant because it's positive, right? So x is equal to beta minus alpha, or x is equal to 2 pi minus beta minus alpha, right? Okay, so if you work it out, then I'm not going to work it out myself here, but x is going to be equal to 0.516 radian, or x will be equal to 4.48 radian. And these are by 3SF. Huh? So that is it for O-Level A-Maths 2010 paper 2. Overall was not a very difficult paper. There have been harder papers, definitely. Maybe it's not the easiest paper ever, but definitely not very difficult. If you've been doing a lot of your practice papers for maybe whatever questions you may have, whether it's your school's prelim papers, other school's prelim papers, tuition, anything like that, if you've been doing enough exercises, you'll find the 2010 O-Level to be not too bad. Okay? If there's any questions about either of these papers, please let me know in the comment section. And as always, thanks for watching.